Hello everyone, I am Janapati Srinu. Who are watching first time my video, subscribe my channel and share to your friends. I came here to explain about basic concepts of chemistry that is related to PG entrance examinations both in Andhra Pradesh and Telangana state. So generally recently they released the notification of TSCPGET, right? Telangana State Common Postgraduate Entrance Test and APPGCET. Andhra Pradesh Postgraduate Common Entrance Test for both who are interested in chemical sciences or chemistry or chemical sciences. You can watch my some videos. I am going to explain different concepts. So generally examination pattern for both examinations, whether it is in Telangana, Andhra Pradesh. So that is 100 questions they will give. You have to do in 90 minutes. 90 minutes you have to do. Generally, previous cutoff for chemistry in Telangana TSCPGET is around 72 marks. You will get the first rank, and 69 something marks you will get the third rank. So for Andhra Pradesh also it is almost in between those only. So generally for any inorganic or organic or physical, analytical, any group you want, you should write the general chemistry entrance examination, chemistry or chemical science examinations. So this who are wants to get the seat in universities of different Usmania University and Andhra University, different lot of universities are there, Palamuru, Kakatiya, JNTU and SV University. So lot of universities is there. So you can get the seat, just you should do some hard work related to these concepts. I am going to deal with all chemistry, but here I am going to explain physical chemistry. Then next inorganic, if time is there, I will also explain some organic concepts. I also done some videos previously in competitive examinations for set net gate examinations. If you want to follow those, you can also follow. I will give in the description link. First I am going to explain about electrochemistry. Electrochemistry. Generally, first I will give some theory related concepts. So then we will go for the competitive questions, how they will ask in the examinations. Right? First, what is mean by electrochemistry? Electrochemistry means simply, generally we will discuss with the two types of interactions, right? What is that? Electrical energy and chemical energy. These are the main important terms. So simply you can say electrochemistry deals with the interactions between the electrical energy and chemical species. Electrochemistry deals with the interactions between the electrical energy and chemical species. So these interactions are two types. Electrochemistry deals with the interactions between the electrical energy and chemical species. These are two types interactions. Electrical energy is converted into chemical energy, and chemical energy is converted into electrical energy, right? So electrical energy is converted into chemical energy is called electrolytic cell. So chemical energy is converted into electrical energy is called electrochemical cell. Electrochemical cell. So these are generally two interactions. Next, the substances which allows the passage of current through it is called the electrical conductor. Next term is electrical conductor. Electrical conductor means the passage of current through it is called the substances which allows the passage of current through it is called the electrical conductor. So generally there are two types of electrical conductors. One is metallic conductor, metallic, or you can say electronic conductor. Electronic conductors. And the second one is electrolytic conductors. Electrolytic conductors. So metallic conductors, examples is metals. Examples is metals. Electrolytic is fused NaCl, etc. Fused NaCl, NaOH, etc. Those are electrolytic conductors. So generally in competitive examinations point, what they will ask, in this concept with the increase of the temperature, generally resistance is increases, conductance is decreases. Same here you can say, with the increase of the temperature, resistance is decreases and conductance is increases. Generally C is equal to 1 by R. Already we know that conductance is inversely proportional to resistance. These are the basic introduction of metallic and electrolytic. So if you will discuss some differences are there, you can write here. Energy is, here you can say simply, mass is not transferred. Here mass is transferred. You can say. Here flow of electrons takes place. Here because metallic or electronic, flow of electrons takes place. Here flow of ions takes place. Both follows the Ohm's law. Mass is not transferred, mass is transferred. Flow of electrons takes place, flow of ions takes place. Here you can say one more point. With the increase of the temperature, resistance increases, conductance decreases. With the increase of the temperature, resistance decreases and conductance increases. This is the introduction about metallic and electrolytic cells. In examination point of view, you should remember, they will ask questions like this. If for example in zinc metal, with the increase of the temperature, what happens to the conductance? Conductance is, here resistance increases, conductance is decreases, you can say simply. Next, electrolytic cell. Next terminology is electrolytic cell. Electrolytic cell means the vessel in which electrolysis is carried out. Or you can say the vessel in which electrical energy is converted into chemical energy is known as the electrolytic cell. You can say the vessel in which electrolysis is carried out, or you can say vessel in which electrolytic energy is converted into chemical energy is called the electrolytic cell. So generally after discussing electrolytic cell, we will go for the electrochemical cell. So in examination point of view, most they will ask questions about the electrochemical cells, like what is the reduction potentials and what is the E cell, E naught cell of the reactions they will ask. So first you should know at least how electrolytic cell is arrangement takes place. So here anode, cathode. Cathode is negative, you can say cathode is negative, anode is positive. So both the in this oxidation takes place at anode, reduction takes place at anode, reduction takes place at cathode. This is the electrolytic cell, right? Electrolytic cell. You should remember this. Cathode is negative, anode is positive. For example, if I will talk about fused NaCl. Fused means only Na and Cl ions are there. That means NaCl generally it gives to Na++ Cl-. So for example, if it is cathode and if it is anode, cathode is what? Already we discussed, cathode is negative, and for negative positive ions comes, that is Na+. For anode is positive, already we discussed. So for anode, the negative ions comes, that is Cl-. So now I will write what happens at cathode. Reduction takes place. Reduction means Na+ by gain of 1 electron, it converted into sodium. And here anode. What happens? Cl-, it gives to half Cl2 plus 1 electron. It releases the electron. This is reduction, you can say, and this is oxidation. Already we discussed the point in electrolytic cell. What is that? Oxidation takes place at anode, reduction takes place at cathode. This is about fused NaCl. So in place of fused NaCl, if I will take aqueous NaCl, right? So aqueous NaCl means only here fused means Na+ Cl- ions are there. Aqueous means some water H+ and OH- also there. So here Na+ Cl- are there. that time we will use the concept of preferential discharge potential. Preferential discharge potential. So that is nothing but electrochemical series based concept that you don't know. First you just listen this concept. Preferential discharge potential. If more than two ions are present, the ions with least discharge potential is discharged first. That means deposits first. If more than two ions are present, the least discharge potential is discharged first. So for example, this preferential discharge potential of cations I am writing K plus Na plus calcium plus 2 Mg plus 2 Al plus 3 zinc plus 2. No need to remember this, just I will give you some clues. And H plus, copper plus 2 and silver plus and Au plus 3. Right. Next, differential potentials of preferential discharge potentials of anions SO4 minus 2 OH minus NO3 minus, you can say NO3 minus OH minus Cl minus Br minus I minus. So cations least discharge potential is this. For anions least discharge potential is I minus. So for example, if two ions are present, zinc plus 2, otherwise you can say copper plus 2, best example we will take copper plus 2 and H plus is there. So which is least discharge potential? Copper plus 2 is least discharge potential, that is first deposited some cathode or anode something we have to take. So this is a comparison. If for example OH minus is there, sulfate ion is there, that time you can otherwise OH minus Cl minus is there. So which is least discharge potential? This is least discharge potential, that is discharge first. So that is concept. This is generally we will use as application for this. First I am going to discuss aqueous NaCl. Aqueous NaCl, right? Aqueous NaCl means it contains Na plus ions, Cl minus ions. So aqueous means water. Water is H plus, OH minus. In this 4 ions are there. First I am writing here cathode. Cathode is negative, right? For negative, positive ions comes. What are that? Na plus, H plus. And for anode is positive, that is negative ions comes. Cl minus, OH minus, right? First I am going to write. So if you observe this Na plus and H plus, which is least discharge potential? H plus is least discharge potential. Anode is Cl minus, OH minus, which is least discharge potential in our previous, that is what? Cl minus is least discharge potential. So for this you can write reaction for cathode. Cathode is reduction takes place. Reduction means H plus by gain of 1 electron, it converted into half H2. Hydrogen gas is released. That is at cathode means reduction takes place. At anode is oxidation takes place. Oxidation is what? Cl minus, it converted into half Cl2 plus electron. So this is what? Oxidation. This is what? Oxidation. At anode oxidation takes place, at cathode reduction takes place. So generally aqueous NaCl is neutral before electrolysis. This is after electrolysis you will get the hydrogen gas and chloride gas. So before electrolysis aqueous NaCl is neutral. Before electrolysis aqueous NaCl is neutral. So after electrolysis what happens? So these two are utilized. After electrolysis what happens? OH minus is present, right? OH minus is present. During the electrolysis OH minus ion concentration is increases. So simply you can say before electrolysis aqueous NaCl is neutral. During electrolysis OH minus ion concentration is increases. OH minus ion concentration increases means what? Automatically it is basic, right? H plus ion concentration increases, that is acidic. OH minus ion concentration increases, that is basic. So if OH minus ion concentration increases, that is basic, means pH is automatically increases. You should idea pH is equal to what? 0, 1, 2, 3, 4. This is the 7 is the neutral, and 8, 9, 10, so on 14, right? So OH minus, so for you should know this 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is the acidic and this is the basic. So OH minus ion concentration increases, basic nature is increases. Automatically pH is also increases. You can see simply this is a statement asked in the examinations, right? Previous examinations. So generally what they asked. So aqueous NaCl during the electrolysis, what is the pH? What is the pH is increases. pH is increases. This is the question they asked in the examinations. Previous examinations they asked this concept. Next we will see one more example. Aqueous copper sulfate, right? Aqueous copper sulfate. So first cathode. So copper sulfate is copper plus 2 plus SO4 minus 2, and aqueous means H plus OH minus. So cathode, right? Cathode is what? Copper plus 2 is present and H plus is present, and anode is positive, so hence negative ions comes, SO4 minus 2, then OH minus. So we will write the reduction. Already we know that cathode is negative, at cathode reduction takes place, right? So if 2 are there, copper plus 2, H plus 2, H plus, hydrogen plus. So which is the least discharge potential? Copper plus 2. Already we done the series, zinc plus 2, H plus, then copper plus 2, then silver plus. This is the Rm plus 3. So if you see, copper plus 2 is least discharge potential. So copper plus 2. Already we know that SO4 minus 2 is there, OH minus is there. So OH minus is the least discharge potential. At cathode what happens? Reduction, copper plus 2, by gain of 2 electrons, it converted into copper. It deposited as copper. Then at anode what happens? SO4 minus 2 is there, OH minus. OH minus you can set, you take 4 OH minus, it can be converted into 2 moles of water plus O2 plus 4 electrons you will get. Oxygen gas is released, copper is deposited. This is oxidation. This is the oxidation process, right? If you observe this, during the electrolysis what happens? Same question if I asking about what is the pH of aqueous copper sulfate during the electrolysis. What happens? During electrolysis H plus ion concentration is increases. So that means before electrolysis it is generally acidic nature of copper sulfate is acidic nature. Before electrolysis copper sulfate is acidic nature. During the electrolysis H plus ion concentration is increases. That means pH is decreases. How you means? So pH is equal to 1, 2, 0, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, right? So hence pH H plus ion concentration increases means what? This. So automatically pH is decreases. So before and after electrolysis pH is going to decrease. This is the concept about preferential discharge potential. Preferential discharge potential. Right. Next, types of electrodes. Types of electrodes. What are the types of electrodes are there? There are two types of electrode. One is inert electrodes. Then second one is active electrodes. Inert electrodes means which do not interact with the electrolytic solution. Is called the inert electrodes, and which interacts with the electrolyte is called the active electrodes. So best example is platinum is the inert electrode, and for active electrodes zinc rod placed in the zinc sulfate solution. Similarly copper rod placed in the copper sulfate solution. Silver is placed in the silver nitrate solution. These are the examples for the active electrodes. Inert electrodes is example for the platinum. In previously we saw like fused NaCl, right? Fused NaCl we saw, and aqueous NaCl. So fused NaCl is made by Downs process. Sodium is made by Downs process. Aqueous NaCl is Nelson cell. We can say Nelson cell. These are the general representations. If they will ask how to prepare sodium means by like fused NaCl using Downs process is also one of the process for this. Next concept, Faraday's laws. Next concept is Faraday's laws. First law of Faraday, very important concept. First law of Faraday. First law of Faraday, right? So first definition, the amount of the substances deposited at an electrode due to electrolysis directly proportional to the quantity of the charge present in the electrolytic solution. Simply you can say the amount of the substances, that is W, amount of the substances deposited at an electrode due to electrolysis is directly proportional to quantity of the charge. This is the representation. Definition is the amount of the substances, W is the amount of the substances is directly proportional to the quantity of the charge. So you can say if you remove the proportional, you will get W is equal to ZQ. So what is Q? Q is the charge, so that is Coulomb. Q is a Coulomb. W is equal to, so Z is equal to I into T. You can say Q is equal to IT. I means current, T means time. This is the first law of Faraday. W is equal to ZIT. So if I will talk, this is the first law. If I will talk about Coulomb, what is the Coulomb definition? Q is equal to IT. So 1 ampere of the current passed through 1 second. 1 ampere of current passed through 1 second is called 1 Coulomb. Passed through 1 second is called what? 1 Coulomb. This is Q is equal to IT. We can say simply Q is equal to IT. Ampere second units. Ampere second. Coulomb means ampere second. So W is equal to ZIT. So what is mean by Z? Generally examinations, in previous examinations also, whether it is in TSCPGET or APPGCET. So what is Z? Z is electrochemical equivalence. Electrochemical equivalence. This is the Z. So already we know that W is equal to ZQ, we know that, right? W is equal to ZQ. If I wanted to write Z, so that is what? Z is equal to W by Q, or you can say Z is equal to W by Q. If 1 ampere of the current, so simply you can say Q is equal to 1. If 1 ampere of the current is passed through the electrolytic solution, the amount of substances W, the weight of the substances is equal to electrochemical equivalence, that is equal to Z is equal to W you will get. So simply if Q is equal to 1, then W is equal to Z. The weight is equal to electrochemical equivalence. This term is very important. Next, second law of Faraday. Same quantity of, next definition is, same quantity of charge is passed through the electrolytic solutions which they are connected in the series. Same quantity of electric charge is passed through the electrolytic solutions which they are connected in the series. That time what happens? The weight of the substances is deposited is directly proportional to the electrochemical equivalence. So simply you can say, for example, 3 cells are there. If I will take, so aqueous H2SO4, this is what? Copper sulfate. If I will take aqueous, then AgNO3 if I will take, these cells are connected in series. So aqueous H2SO4, copper sulfate, silver nitrate. If I will use cathode is hydrogen, copper and silver. Simply which they are connected in the parallel. Same quantity Q Q is same quantity of charge is passed through the electrolytic solutions. The amount of the substances, that is W, H2, or you can say W copper and W silver. This is equal to what? It is directly proportional to their equivalent weight of copper, E silver. So you can say WH2 means EH2 is directly proportional to same quantity of charge is passed through the electrolytic solution. You will get the equivalent weight. W is equal to EH2. How we will see now. If two cells are, I will take W1 by E1 is equal to W2 by E2. Otherwise you can see simply directly. Here we will see W is directly proportional to E, right? Here that means W is directly proportional to E. So you can say W1 by, otherwise you can write like this. W1 by E1, you can say W by E is constant. Like this, W by E is equal to constant means what? Directly proportionals. W1 by W2 is equal to, so W1 by E1 is equal to W2 by E2. Both are same. W1 by W2 is equal to E1 by E2. Both are same, right? So next W. What is mean by W? W is ZQ, right? Already we written Z1 into Q by E1 is equal to Z2 into Q by E2. If you observe clearly, yes, Q is what? Same quantity of charge. Same quantity of charge is passed through the electrolytic solution. So you can say Q and Q are cancelled. You will get Z1 by E1 is equal to Z2 by E2. So simply you can say that Z1 by Z2 is equal to E1 by E2. So it means E is directly proportional to Z. E is equal to directly proportional to Z. If I will want to remove this proportional symbol, you should use some constant. E is equal to Fz. This is the very important in the second law of Faraday. E is equal to Fz. Now the term is Faraday, right? What is mean by Faraday? If someone will ask, what is the Faraday value? Faraday. What is Faraday F? Everyone knows that F is equal to what? 96,500 coulombs, right? So Faraday definition, if someone will ask what is mean by Faraday means charge of the 1 mole of electron. Charge of 1 mole of electron is called 1 Faraday. So first charge is what? 1.602 into 10 to the power of minus 19 coulombs into 1 mole of electron. It means Avogadro number. That is what? 6.023 into 10 to the power of 23. Right? 10 to the power of 23. So here 10 to the power of minus 19 is there, 10 to the power of 23 is there. You will get what? 10 to the power of 4 you will get. 3 plus 1. Simply you can write minus 19 plus 23. Whenever bases are same, you can add the powers. You will get the 10 to the power of 4. Here 6 into 1.6 is approximately 96. 6 into that is 9.6 you will get 9.65 something. So if you will add this 4, Faraday is equal to 96,500 coulombs. It is not approximately 96,499 something you will get. So the value is F is equal to 96,500 coulombs. So Faraday means you can say simply charge of 1 mole of electron. We will see some definitions of Faraday. So it is very helpful for further examinations. 96,500 coulombs, or you can say charge of 1 mole of electron. Or you can say 1 gen. Gen means gram electroequivalence weight. And if I will take 23 grams of sodium, 23 grams of sodium means directly you can say equivalent. What is the 23 grams of sodium? 23 is the equivalent to direct Na plus ions. 23 grams of sodium is 1 mole of sodium. If I will take 12 grams of magnesium. So generally magnesium weight is 24, magnesium charge is by 2. So that is what? By 2, equivalence weight by 2 means 12 grams. So that is half mole of magnesium. and 9 grams of aluminium. 9 grams aluminium weight is 27, aluminium is charge is 3, 27 by 3 if I will take, so you will get approximate, you will get 9 grams of aluminium is 1/3 mole of aluminium. 1/3 mole of aluminium. So 20 grams of calcium. 20 grams of calcium is equal to half mole of calcium. Half mole of calcium, because calcium is plus 2, calcium weight is 40, 40 by 2 is 20. So you can say Faraday definition, 1 Faraday is equal to 96,500 coulombs, or you can say, so 12 grams of magnesium, that is equal to 1/2 moles of half mole of magnesium. You can say the different definitions like this. So some more definitions are there, we will see. So here 1 Faraday means we can use 31.75 grams of copper. Copper is equal to what? 31.75 grams of copper means what? Half mole. Same, copper is plus charge. So same copper weight, you should double this, you will get this half mole of copper. And 32.7 grams of zinc is equal to half mole of zinc. 108 grams of silver. 108 grams of silver means silver plus charge, silver weight is 108. 108 by 1 you will get 1 mole of silver, you can say 1 mole of silver. Here 1 Faraday means 1 gram of hydrogen if I will take. 1 gram of hydrogen weight is 2, 2 by 1 is, so 1 you will get. So that is half mole of hydrogen. Half mole of hydrogen. So generally for STP, so it occupies the 22.4 liters. 1 liter STP, the volume occupied by gas is 22.4 liters. So half mole means, so for one mole it occupies 22.4 liters. So half mole means by 2 you should do. 22 by 4 is 22.4 by 2 is what? 11.2 liters of hydrogen, you can say. 1 Faraday means you can say half mole of hydrogen, or you can say 11.2 liters of hydrogen. So then if you want to write oxygen, O2 weight is 16, O2 weight is 32. O2 weight is 32. So I am writing 80 grams of oxygen is equal to 1/4 moles of, here if I will take 32 by 8 means what? 4 is a. So 1/4 mole of oxygen. Here same 2 by 1, you can get 1 by 2. So you will get same 22.4 by 4. You will get 5.6 liters. 5.6 liters of oxygen. 5 liters of oxygen. Then next if you want to write 35.5 grams of chlorine, you can say half mole of chlorine. Half mole of chlorine, that is equal to 11.2 liters of chlorine. These two are very, very important for competitive examinations. Simply, if we will take half mole of hydrogen means you can take 5.6 liters of oxygen also, both are same because it is equal. So 1 Faraday definition. So one question I will explain how the examinations they will ask. One question I will explain regarding this. Question is like this. For example, for acidified water, 0.224 liters of hydrogen is formed. Liters of hydrogen is formed. Hydrogen is formed at cathode. Then how much volume of oxygen is releases at cathode, releases at anode. This is the question. They give the 0.224 liters of hydrogen and they asked in terms of oxygen volume. First we know the previous definitions. 1 Faraday is equal to 11.2, 1 Faraday is equal to what? 11.2 liters of hydrogen. 11.2 liters of hydrogen, that is equal to what? For 11.2 liters of hydrogen means what? We can say 5.6 liters of oxygen. 5 liters of oxygen. Both are equal. So now what they given? 0.224 liters of hydrogen. 0.224 liters of hydrogen they given. So they asked the how much volume of oxygen is released. How much volume of, this is say, let's say x. X is equal to what? 5.6 by 11.2. Cross multiply 5.6. Otherwise you can say x is like this and 5.6 like this. This is a cross multiply 5.6 into 0.224. So this is 5.6 ones are 5.6 twos are 0.224 means 0.112. So x is equal to 0.112 liters of oxygen is released. Oxygen is released. This is the questions. General pattern of questions is like this. This is what acidified water. So this is a general whatever the question they will give you, whatever the value you want, just you should equate that. You will get the Faraday value. Then that time you can calculate the everything. So this is about first terminology we discussed, and Faraday's laws we discussed, and pH values of aqueous NaCl, aqueous NaOH, that already we discussed everything. In next class, very important class, we will discussing about what is that specific conductance and specific conductance, equivalent conductance, molar conductance, their units. We will discuss in the next class. So who are watching, who are like my video, subscribe and share to your friends. Thank you so much.